this lesson is review of factoring. So I'm going to try to show you, again, some various methods of factoring. But again, a review, one of the first things we have to know is GCF. So again, in this situation where you have two numbers, you can use the calculator. Remember, it's under the math button. But what's the biggest thing that will go into 14 and 12? Well, they're both even numbers, so you know 2 will go into them. And you try to think of anything bigger. Well, in this case, that's it. So you do 2. 2 times 7 is 14. The 2 times 6 is 12. And then that one is factored. All right, let's look at another example here. Okay, so let's take problem number 2. I'm going to try to cover up some of these others here so we don't see them as we go through them. So problem number 2. Again, always look for GCF. Try to think what's the biggest thing that'll go into them. Now in this situation, because we have 3 things, I can just slide this over a little bit so you can see it. You always look for a common variable. Well, in this case, this does not have a v, so you can't take out a common variable. So all we can deal with here are the numbers, 36, 8, and 16. Again, they're all even, so you know 2 will go into it, but then you try the next even number, which is 4. Well, 4 will go into all those, so you take out a 4. 4 times 9 is 36. 4 times 2 is 8. And then 4 times 4 is 16. Then I cannot factor this, and the reason I can't factor this is because this is not a square. Remember, we can only factor quadratics, so that has to be a square. So GCF is all we could take out of that one as well. All right. So let's move on here. And again, I'm going to erase some of these so I can see them to do them. Let's go ahead. Do this right here. All right, there we go. Okay, so again, we're going to start with GCF. So we look here, 3, 51, and 210. I can take out a 3. So if I take out a 3, that leaves r squared. 3 times 17 is r, or 51, sorry. And 3 times 3 goes on 21, 7, 0. 3 times 70 is 210. Now, once we have it to this point, now we're back to just normal factoring. So remember what we talked about, factors of 70 that add to give me 17. Remember, if they add, they're the same sign. They're both negative here. So again, if you need to, you can make a list. So 70, that would be, and you can start with -1, -70, and go through your list, or in this case, I know it's going to be -7, -10. So then my factors here are r minus 7 and r minus 10. Okay. Good. All right, now let's go to number 4. We'll slide it over a little bit here, and let's just go ahead and we'll get rid of some stuff here. Oops, sorry about that. Well, I just keep getting rid of the wrong stuff. I don't want to get rid of all that. Okay. There we go. Now it's cleaned up a little bit better. Okay, so let's start with looking for a GCF again. Okay, so is there anything that'll go into 3, 14, and 16? And there's not. So here we're going to have to do bottoms up method. So the first thing we want to do is we want to take our 3 times our 16. Sorry. So that's 48. So now this becomes x squared minus 14x plus 48. Okay. Now factors of 48 that add to give me 14, and that's going to be x minus 6 and x minus 8. But then we have to deal with the 3 again right here. So 3 will go into 6, but 3 won't go into 8. So remember, if it won't go into it, it goes to the front. So this now becomes x minus 2, and that becomes 3x minus 8. And then there are our 2 factors. Okay. Let's get rid of that. Let's scroll over again. So number 5. So again, I'm going to overwrite this, get rid of this. Okay. GCF. What will go into all those? 10, 27, and 18. 2. So I take a 2 out. What's that going to leave? 5p squared. Nope. Sorry, 2 doesn't work because 2 doesn't go into 27. So let's try again. Oops. 3 will go into 27, 8, but it won't go into 10. So you got to kind of think through these again. So it's not always just straightforward. So in this case, there's not anything. So again, we're back to bottoms up. 10 times 18 is 180. So now that becomes p squared minus 27p plus 180. All right, now this is a big number, so this could take a little bit. So I'm going to start just listing my factors. I know they're relatively close. So let's see. Let's try 10 and 18. Well, 10 and 18 give me 28, not 27. Okay. So what about 11? 11 won't go. What about 12? 12 will go. 12 and 15. There we go. There's negative 27. Okay. So we have p minus 12. And we have p minus 15. Again, we have to deal with our first term, which is 10. Well, here, remember, 10 won't go into 12 evenly, 10 won't go into 15 evenly. Okay, so 10 won't work. So what's that mean? Remember, we have to break down 10, so that's 2 and 5. Okay, well, 2 will go into 12, which means the 5 has to go here, because remember, the 2 have to give me 10. 5 will go into 15, which means the 2 goes in front of that one. So I'm left with 5p, 2 goes into 12 6 times. And then here I'm left with 2p, 5 goes into 15 3 times. It's always a good idea to double check, do FOIL. It's 10p squared, negative 15p, negative 12p. That gives me negative 27. And then negative 6 and negative 3 multiply to give me 18. So that does work. All right, let's go to number 6. Number 6 you might recognize as a special case. First, do GCF again. Always start GCF. So here I can take out 3. That's going to leave x squared minus 4. And then this one is again that difference of squares. That's a square. What do we square to get 4? 2. So if you remember, when we did difference of squares, we always had 2 cases. One case is a plus, so x plus 2. The other case is a minus, x minus 2. And that's why we're missing that middle term again, because these are opposite, so they cancel out. All right, one more problem to do. Number 7. Okay, here I have 4 terms, so immediately my first thought is, okay, I need to do grouping. Got to do grouping. So remember how we did grouping. We grouped by 2, so I grouped the first 2 and group the second 2. Then we do GCF. Out of the first 2, 5 and 15, that'll be 5. We'll go into both of those. And then they both have ends. How many ends can I take out? 2. Because the second one only has 2 to give me. Now if I do that, that's going to leave 5 times 1. So I can write the 1 if I want to, or I don't have to. Sorry. So 5 times 1. And again, 5 times, let's see, n squared, n, because I had 3 n's. Again, you can put the 1 there, but you don't have to. All right, 5 times 3 is 15. Took both the n's out already. All right, look at the second group. Remember, we always said pay attention to the sign, plus what'll go into 3 and 9? 3. What's that leave? That leaves n and then 3 times 3 is 9. Remember what we said, these should always be the same. And they are, so that's n plus 3. Then I group what I took out. So in this case, that's going to be 5n squared plus 3. And then that one's factored. So a good review of factoring as it's necessary in helping you solve quadratic equations.